Well, it's Friday, which doesn't mean as much as it used to a lot of us. But anyhow, yesterday we got these properties of exponents listed at the top of the paper. And what we're doing today is really just a combination of using those properties and using the distributive property. So you might remember that when we have something like this is all numerical, obviously. This is 5 times that. What is this? This is 7 and 1 is 8 and 2 is 10. So this is really 5 times 10, which of course is 50. If we use the distributive property, let me zoom in a little better here. If we use the distributive property, we could say this is the same as 5 times 7 plus 5 times 1 plus 5 times 2. And you notice if you add these 35 and 5, you get 40 and 10. You also get the same answer, 50. Okay, so that's just a demonstration of how that process is legal, mathematically legal. We come down here, multiplying a monomial, a single term expression, times a polynomial, with a term that might have 2, 3, or more terms in it. We're going to use the distributive property to remove the parentheses. So we do 5x times minus 3x, and we multiply the coefficients, you get negative 15. The x times x makes the x squared. Then plus 5x times 7, well, that's just 5 times 7 times x, 35x. And we stop right there. These are not like terms. They cannot be combined. Okay. Guess I'm going to go down the paper. X squared times 4x minus 3. We do x squared times 4x first. We put the 4 out in the front. The x squared times the x to the first makes it x to the third. And then minus x squared times 3. Get minus 3x squared. And that's the end of that one. Third one down in the first column. I'm going to do 3 multiplications here. First, negative 2 times 6 makes a negative 12. And the x to the third times the x to the second. We add the exponents. We get x to the fifth. And negative 2 times 3, we get a negative 6. And the x to the third times the x to the first, we get an x to the fourth. And last, negative times negative, we get positive 8x to the third. That's that. And the last one in the first column, multiplying that, you get 28. X to the 3 plus 2 is 5, and then minus, positive times negative makes it negative, 20, x to the third plus the invisible 1, we get x to the fourth. And lastly, 4 times 6, that's plus 4 plus 6, get plus 24 x to the third power. Go up to the top of the second column. This is sort of backwards, but you know we can do it this way. Do that times that, and then do that times that, or you can rewrite it backwards. Whatever you're more comfortable with, you'll get the same answer. Minus 3x times 5x, we get minus 15, and x times x makes the x squared. And then plus 7 times 5x, that's 7 times 5 times x, so that's 35x. Okay, and that is the same expression as over here. It's just the order of multiplication has been reversed, which is okay because multiplying backwards is okay. Multiplication is, what's that fancy word? Commutative. All 4 terms in here get multiplied by the 3x squared, one at a time. So when I do this times this, the 3 times the minus 3 makes a minus 9. And x to the 2 plus 3 is 5. And then this times this. The 3 times the minus 11 makes that minus 33. X to the 2 plus 2, x to the 4th. And then this times this. 3 times 6. They're both positive. We get plus 18. X to the 2nd times x to the 1st. You get x to the 3rd. And lastly, 3x squared times the negative 1. The 3 times negative 1 makes a negative 3. And the x doesn't change because there was no other x to interact with it. So there's our answer for that. And no like term, so nothing can be added or subtracted. And here's one more with 4 terms to be multiplied by negative 4x to the 5th. So negative times negative, that makes positive. It's like there's an invisible negative 1 there. Positive 4. X to the 5 plus 3 is 8. Then negative times positive. It's like an invisible positive 1 coefficient there. Negative 4, x to the 5 plus 2 is 7. And negative times negative, positive. 4 times 9 is 36. And the x to the 5th times the x to the 1st makes it x to the 6. Lastly, negative times positive makes negative 12. X to the 5th power. No other x to make it change. And, oh no, fractions. Oh my gosh. Well, we'll see. Maybe it's not so bad. Calm down, Mr. Dane. Positive times negative makes it negative. And 4 times a half, that's like a half of 4, makes it 2. That didn't hurt too much. And x times x to the 3rd, x to the 4th. And positive times positive, positive. Now 4 times 1 over 4, that's 1/4 of 4. That just makes a 1. We don't need to write the 1. If you write the 1, it's not incorrect. It's unnecessary though. And the x times the x squared makes x to the 3rd. And then positive times negative, negative 20, x to the 2nd. And finally, 4 times 5 makes 20. X to the 1st power, just plain old x. Okay. And that's the end of page 1. So I'll stop this and make a separate video for page 2. Bye-bye for now.